All right, so given y equals this here, we want to find dy dx. These are some of the FYIs that I may need along this process. So let's see. We want to find dy dx, so let's take the derivative of both sides. So the derivative of y with respect to x would be dy dx. Now over here, notice everything is in terms of x, so that's good. And now let's apply the quotient rule. So we want the bottom times the derivative of the top. So let's keep the bottom as is. And then it's the bottom times the derivative of the top. Let me open up some parentheses. So the derivative of the top, the numerator is a product. So let's take the derivative of this, where this is a product rule. So remember product rule, you go derivative of this times that, plus the derivative of this times that. So check it out. I did the derivative of x, it's 1. So the derivative of this times that, that's what this is. And then plus, and then the derivative of this, which is that, times that, which is why that's x. Because the derivative of cosh x is sinh x. So that's the quotient rule. I did bottom times the derivative of the top, which is all of that. And then remember, it's minus, then it's the top times the derivative of the bottom. Now, what's the derivative of sine inverse? It's down here. The derivative of sine inverse is 1 over the square root of 1 minus that thingy squared. So here's what that would look like. So the derivative of sine inverse is going to be 1 over the square root 1 minus that thingy, whatever that is. It's a copy and paste squared. But then I put a dot because there's a chain rule. Because you've taken the derivative of sine inverse, which is here, but then you have to multiply by the derivative of that object there, of that function. And the derivative there would be 18x squared. So far, our quotient rule, we've done bottom times the derivative of the top minus the top times the derivative of the bottom, is there, all over the bottom squared. Now look, this is the answer. They wanted us to find dy dx. Here it is. That is the answer. Can we clean this up? Probably. Do they want us to? I don't know, but let's do a couple of little things here. So let's see. That stayed out there. In here, I put x in front of sinh, and I put sinh before cosh, just preference, subtraction. And then I said x times x squared is x cubed, along with 18 upstairs, along with the cosh, and I drop that below. The denominator stays as is. And again, can this be cleaned up? It can if they want us to. I just don't know how picky the instructor is. Are they okay if we turn this in? If they are, great. If not, I suppose we can do some more stuff. I just don't know what they want from us. So for now, let me just submit that this is one version of the correct answer. If they want us to simplify it more, let me know and we can run through some more algebra. So let's take the derivative of each of these pieces independently. Let's focus first on the x equation. So let's take the derivative of x with respect to t. So let's go derivative. So the derivative of x with respect to t would be dx dt. So the derivative of that is that. And then what's the derivative of this? Well, what's the derivative of natural log? Over here, the derivative of natural log is the reciprocal of the argument. Here the argument is 3 minus t. So it would be 1 over 3 minus t times, chain rule, the derivative of the inner function. The derivative of that would just be -1, because the derivative of negative t is just -1. And that's really just dx dt. Now let's find dy dt. So take the derivative of y with respect to time, or with respect to t, whatever t represents, dy dt equals. Now what's the derivative of this here? This is the inverse of hyperbolic tangent of that. Well, let's see. Over here. So the derivative of that is 1 over 1 minus that thingy squared. So what should go in here? Whatever object that is, square root t. But then recall that you immediately multiply by the derivative of this function based on the chain rule. So what's the derivative of square root t? Well, recall that square root t is the same as t to the 1/2. So let's take the derivative of that because these are the same thing. And the derivative of this would be 1/2 t to the minus 1/2. So this is dx dt and this is dy dt. Let's clean this up a little bit. So let's see, I put the -1 in the top, and then I made the -1 positive because I threw the negative to the bottom, which is going to reverse the order of the terms. That's a neat little trick. Over here, let's see, so t to the -1/2, I sent it to the bottom because the negative power moved it from top to bottom, and I just rewrote it as a square root instead of a 1/2 power. I kept the 1/2, I just put the 2 in the bottom, same thing. And then that's 1 minus the square root of t squared is just t, so I put that in parentheses. So here we have dx dt, and this is dy dt. But what do we want? We want dy dx. So let's do something here creative that will create dy dx. And here is what I propose. I propose that we go dy dt divided by dx dt. Because if we do that, recall that this is the same as dy dt times the reciprocal, right? Instead of dividing fractions, you can multiply by the reciprocal of the latter fraction. And if you do that, these dt's would knock out, so we'd get back dy dx, which is what we want. So let's do that. Let's go dy dt, which is this, and let's divide it by dx dt, which is that. Okay, so that's dy dt divided by dx dt. And so let's reciprocate this one and turn this into multiplication. And honestly, there's really nothing else to do except just to write this as one fraction. And this is what they wanted. This is equal to dy dx. But again, I know I keep repeating myself. I don't know if they want this to be cleaned up any further. We can like rationalize the denominator and do all kinds of stuff. Let me know if they want us to do a little more cleaning. But if not, as is, this is one version of dy dx.